Coming back to the formula. All right, well, here's where I like the term rise with a y over the run, because the formula m, right, commonly our slope is our rise over our run. Our slope is denounced m, and we'll talk about with that mx plus b in linear equations. They tell us y2 minus y1 over x2 minus x1. Well, look what's going on. Well, let's count, and we're going to show that it really doesn't matter which one you pick, because what's going to happen is if you were to put, and I say put your y in your top, so you have the 1 and the 6, minus, put your y in the top and your x in the bottom. Think about it as each order pair, and you're going to see why it doesn't matter here. 1 minus a negative, okay, well, that ends up being a plus, ends up being 3 over 6 minus a negative, ends up being a plus 9. You'll see it ends up being that same 1/3. Well, watch what happens if I were to swap those. And that's where, again, you think of it as the y in the top, x in the bottom. But say I swap those. It doesn't matter which one's your 1 and your 2 coordinate, because you're going to have -2, -3. It's still the y in the top, x in the bottom. Minus, because it's always subtraction, right? That's the distance between 2 points. 1, 6. -2 minus 1. Watch back to the videos, right? If I owe $2 and owe another buck, I owe $3. If I owe $3 and I owe $6, that's owing $9. But watch what happens here. Those negatives cancel, and it ends up being the same 1/3. It ends up being that same rise over run. So I like to sometimes just sketch that out and see what's going on, but at the same time, it won't make any difference because it all ends up getting you the same answer.